This is just a quick little look at some of tonight's homework. So we have a couple tables here and a graph that we're looking at. So I'm going to zoom in on that first table. And, excuse me, we're going to find the slope from each of the points. So this would be point 1, point 2, point 3. So if I went and found the slope, which again, from yesterday, is change in y over change in x. So if I start at 2 and end at 4, that's a change in y. That's a slope of 2. And from those same points, x values, we go from 5 to 6 was a change of 1. So you can see that situation between these 2 points, I have a slope of 2 over 1. Let's do a different set of points. Let's go from 4 to 6. That's also a slope of, or an increase of 2. And the corresponding x values, we're going to go up 1. So that situation is also a slope of 2 over 1. And then if I went from the first point down to the last point, here it's a little different. We go from 2 to 6. That's a slope of 4. And I go from 5 to 7. Sorry, I said that's a slope of 4. It's actually an increase of 4. And from 5 to 7 is an increase of 2. So that looks different. But if you reduce it, you still get the same slope. So if all three situations, if all three combinations have the same slope, then it's safe to say that it's a linear situation. Let's look at the second one here. And we're going to see fairly quickly how this falls apart. So if we go from 3 to 6, that's an increase of 3, so plus 3. And that's an increase of plus 1. So the slope between these two is 3 over 1. And if I go to the second set of points, 6 to 9 is up 3. 2 to 4 is up 2. So the second set of points has a slope of 3 over 2. So this situation would therefore be non-linear. So it's important to have a quick way to find slope. And this delta y over delta x is a good way to do that. Here is a graph. And I think this one's much easier to kind of see, oh, is this a linear situation? If you can draw a line right through all 3 points simultaneously, meaning the points are collinear, then it's linear. But in this situation, you see I have those 2 points can be hit by this line, these 2 points by this line, and these 2 points by that line. Essentially, if I want to connect all three, I've got to use a triangle. So that means that these 3 points are also non-linear. I'd have to use some sort of curve to hit all 3. All right. An example of something that is actually linear would look more like that. And as you can see, if I try to connect all of those points as straight as line I can, I've got nice software here that's going to snap that to a nice line. And you can see that one line hits all of them. So I can clearly make the case that that is linear with a lot of excitement.